The second and third week, we went through Marina Bay Sands background, design issues, and foundation phase. Today, we are going to continue to talk about the construction of hotel towers introduced last week. Before that, let's briefly review the last presentation. We went through the design concepts and geological features of the Marina Bay site. In relation to this, we introduced many of the construction methods used in the foundation and excavation phase of the hotel towers. And last week, we talked about a solution that allowed the building to erect up, overcoming the overturning caused by the slope of the building's lower part. The key point was the post-tension method. Furthermore, they used creative ideas of inserting a lot of tendons inside the building walls to pull the inclined structures. Thanks to this new technique, they were able to pile slab layers without collapsing. However, since this vertical post-tension technique had never been tried, engineers needed a more sure way to prevent collapse. They had to eliminate the possibility of failure with more certainty. So, two additional techniques were used with vertical post-tension. The first one is the temporary bracing, and the second one is transfer truss. Today, we will deal with these two construction methods mainly. First, temporary bracing. Temporary bracing is the large temporary struts made of strong structural steel for transferring part of the inclined building load to the vertical building. As a result of the structural analysis, the three sets of 8 temporary braces were the most efficient and installed on the 8th, 14th, and 20th floors. Each strut is designed to withstand a permissible load of 1,000 tons. After the 8th slab is laid down, stressing is done to the tendons inside the wall. Then, after the 9th slab is laid, one set of steel struts is installed diagonally. The vertical structure was applied with stress to the tendons at intervals of 6 floors, and the leaning structure was applied at intervals of 3 floors. The second set of steel strut is installed after the 15th slab is laid out. In the same sequence, after stressing tendons, final set of struts is installed at a height of 20 stories. Since the load was concentrated on the first floor, the concrete supports called RC corbel were installed, and struts were connected onto them to prevent cracks or deformation. Hydraulic jack was installed at the wall connection to remove the load when the temporary braces were removed. Because the struts received a large load of more than 7,000 kN and the span was low, the two main steel frames were connected in truss form. The strength used is S355 with H-beams and braces forming truss structure. As the building went up, temporary bracing delivered the load of the inclined structures to the vertical structures. This could resolve the challenging slope successfully, along with post-tension method. To withstand increased loads, tendons were also inserted into the vertical structure. The struts were removed later and provided people with attractive empty space. Suppose there are 4 same blocks. Then make 2 pairs and place the books on them. At this time, one pair is vertical both and the other is tilted. Which group is more stable? Of course, the vertical one. A tilted structure collapses easily, even with a small force. Now, think of Marina Bay Sands hotel towers. The 3 sloping buildings support more than 60,000 tons of superstructure. Even with the same load, sloping structures are more vulnerable. If the 2 structures do not move as one, the sloping structure would slip or break. The key to making the 2 structures move like one is this jet shape. This is the 23rd floor of the building, where the plant room is located, performing a vital role. Without this floor, the 2 walls would act independently, and significant differential displacement would occur across the corridor at the upper levels. This would have resulted in unacceptable cracking and out-of-level floors. This is what it looks like inside. Then, how did they adjust loads? Please look carefully at this triangle shape. Inside the wall on the 23rd floor, large steel structures called the transfer truss are installed. This structure literally transfers parts of the inclined structure's loads to the vertical structure. The inclined structure is designed to receive the 40% of upper load, and the vertical one is designed to receive 60%. It is an important structure that permanently reduces the load acting on a sloped structure to prevent deformation of a building. Because it was a very huge and heavy structure, the workers divided it into 30 units and lifted by a crane and assembled. This is field picture in working. Through where the 2 buildings meet, they could move like one body. We were curious about the actual load distribution. We'll look at the design, draw it, and then analyze the load distribution. Assuming a total load of 100 kN, the result was that 55 kN was applied to the vertical structure and 45 to a sloping structure. It was similar to the information we obtained.
Let's take a look at the collateral construction of the Marina Bay Sands Hotel. First, jump lifting. Let's talk about how they moved building constructions. In the simple process of moving the building blocks, this building used a new construction method, which is called jump lift. The conventional method of installing the lift is to start the installation work of the lift once the frame construction is completed to the machine room of the lift and the machine room is handed over to the lift installer. However, this construction method was too long for the construction period to occur inside the lift, and the construction finishing process of the lift lobby parts was also affected because it affected the entire construction period. Accordingly, in order to install the lift, it was necessary to shorten the construction period and to find a way to install the lift without affecting the construction finish. The new construction method applied to the site is jump lift installation. This method is a system in which a temporary elevator is installed inside the shaft following the progress of the lift shaft frame and replaced with a permanent elevator after completion of the frame after use. In this method, 2 decks are installed in accordance with the progress of the upper frame, and after installation work inside the lift shaft, the construction period can be shortened. When construction has reached the floor set in the jump plan, the mobile machine room is installed and the elevator can begin to serve the first few floors. As the building grows higher, jump lifting follows, with new floor being served after each jump. There are three main advantages to using this technique. The first is shortened construction period. The jump lift is not affected by the weather because it runs inside the building. Also, unlike the hoist for construction, it is said to be able to operate 24 hours a day with very little noise. The second benefit is increased safety. Because it is located inside the building, self-falling, outside fall, and accident can be prevented beforehand, so the worker can work safely. Also, unlike a hoist, it shows a stable ride with less noise and vibration. A third advantage is the earlier availability of permanent elevator. Since the elevator is installed at the same time as the construction work, the elevator can be used as a passenger elevator, which can shorten the finish time of the building. With this method, Marina Bay Sands was able to complete the elevator installation in just 36 days and complete the project 4 months earlier than expected. Although these new technologies are introduced, the Marina Bay Sands Hotel has a great risk of construction. Therefore, in order to prevent accidents, real-time monitoring is applied. And if the estimate is exceeded according to the pre-structural analysis, a technology is applied to notify the site staff immediately for prior action. Two major parts of real-time monitoring technology have been applied in this hotel construction: strain gauge, tiltmeter. Let's take a look at these technologies. First, strain gauge. A strain gauge is a sensor that measures deformation for external forces. As the concrete expanded under a tensile seal, the sensor attached to the surface also stretches, making the path thin, resulting in greater resistance. Using this principle, we can really measure the tensile force that concrete receives. This strain gauge allows us to monitor the tensile force of concrete, the force acting on RCPT beams that binds vertical and sloping buildings, and the strain stress on the steel truss. Tiltmeter is a machine that measures slope. It has been used in volcanic areas and dam construction, which has to be sensitive to fine tilt, but it is used in modern times to construct skylines. The Marina Bay Sands Hotel installed a tiltmeter on the wall to monitor the vertical-horizontal displacement in real time. The green color is tiltmeter, and you can see that it's arranged almost every floor as follows. A graph of displacement of Tower 1 slope building. According to the analysis, the horizontal maximum displacement of Tower 1 is 20 floors. It was considered to occur about 150 millimeters. These monitoring results are available in real time through the internet, and the system was designed to automatically send SMS characters to the person in charge when the risk level is reached. Today, we presented about the construction of hotel towers. Thank you for watching this video.